The advanced thermostat vividly demonstrates the relationship between current, the number of appliances you are using in your home, and how a circuit breaker works. It also demonstrates the mechanics behind an analog thermostat. The apparatus comes with a bimetallic bar, incandescent and LED bulbs, a multimeter, and a candle. There are also digital assets available so students can apply these concepts to their own home. You will need to provide a 6-volt DC power supply. The first experiment is to demonstrate how a circuit breaker works in your home. Place in all the incandescent bulbs and make sure that all the switches are in the off position. The next step is to adjust the contact bolt. You want to make sure this is just barely making contact with the bar. So as the bar heats up, it will bend away, breaking the electrical contact. Next, you connect a power supply and then a multimeter set in ammeter mode. Eventually, the current will heat up the bimetallic bar, and as you can see, it already faded away enough that it bent this away, not making contact, therefore cutting the current. If you repeat the same experiment with LED bulbs, you'll notice that the current is significantly less. So how can we use this to demonstrate how a thermostat works? A traditional analog thermostat uses a metal bar that bends due to temperature changes. The conductive liquid inside creates a circuit to either engage the furnace if it's bent to one side, or an air conditioner if bent to the other. We're going to use this one bulb as an analogy to being the circuit that's controlling your furnace. If you set the thermostat to a specific heat, the bimetallic bar has to bend away in order to break the circuit. So the furnace is going to keep going and going and going, and the candle will represent the ambient heat of the room. And when that ambient heat gets to your desired position, eventually that heat will cause the bimetallic bar to bend away and break the circuit. There are also digital assets that come with the thermostat. One of them is called household electronics. And from this, students are going to identify all the electronics in a room, investigate the power that they each use, and there is sample data, and they can also go online to find this. After they identify every electronic in a room, how much power do they use, how much current do they use, and then they're going to divide that up into zones. Typically, a circuit breaker is 15 amps or less, so they want to break this up into something that's 15 amps or less. So this would be one circuit breaker. This would be a second circuit breaker. Also, is it something that's being used occasionally or something that's on all the time?